Hello, my name is Rob Reynolds. Welcome to Mat-074. Today we're getting our first section from Chapter 4. We're going to be exploring polynomials today, looking at the difference between terms and degrees and coefficients, a bunch of definitions, how to combine like terms for polynomials, and then how to add and subtract, talking about this oppositeness. So first of all, a monomial is like a monologue. Jay Leno or Johnny Carson or whoever you're listening to, David Letterman retired, so sorry. Monologues, one person, one term. A polynomial would also be like a larger set of a monomial, which would be one term. A binomial, which maybe you've seen like x plus 5, is considered a binomial because it's two terms. And then a trinomial would be something like x squared plus 5x plus 6. These are all polynomials, but this monomial is a special polynomial. So it's kind of a subset of the bigger set polynomial. So examples of polynomials, this is a monomial, one term. This is a monomial, but this is a trinomial. And this is just a constant. Some things that might be of interest that are not polynomials are if you divide by x, or raise x to the negative exponents, take the square root of x, or fractional exponents. These are not polynomials because they're not smooth and continuous. So if you look at the graphs of these things, they either have asymptotes or they're not, the domain is restricted. It's not all reals, and it's not a nice smooth function from negative infinity to positive infinity. So everything in green, not polynomials. Everything in red, nice polynomial functions. So 4 is said to be the coefficient. The degree of the term is the highest exponent, but if you have more than one exponent, you add them up. So this whole term, remember terms are separated by addition and subtraction, so this is just one term. The degree here is 9 because you're just going to add those exponents up. So here, the leading term, again, terms are separated by addition and subtraction, and there are 1, 2, 3, 4 terms. But the leading term, with usually the highest exponent, would be 3x to the 4th. The coefficient of the leading term is 3. Coefficient is the number out front, and its degree is 4. Let's see if we can check some of those answers. Yep, 3x to the 4th, 3 and 4. Same thing here. The leading term for this one would be the whole 5a to the 4th b, the first term. I was just looking to see, well, I wonder if 11 is the leading term because the exponents here, at least the sum of those exponents is 6. So it would be a degree 6 opposed to this would be a degree 5. So we should probably rewrite this in descending order first because I think the highest exponents here would be to the 6th degree. So if I were to reorganize this, just so that we can have some kind of terminology about what the leading term should be, well, the leading term should be the highest degree. And in this case, the highest degree is to the 6th because 2 plus 4 is 6. So I think this is a 6. The leading coefficient of that would be 11 opposed to the 5. And then the leading term, I think the leading term should be 11a squared b to the 4th. Let's see if the author agrees with me. Hopefully we have the same definitions. Yep, good, good, good. So this one requires the commutative property to kind of reorganize our thoughts a little bit. So again, putting things in descending order means put the highest degree first. So here the highest degree would be x to the 7th, and notice they're placing that first. Then followed by the x squared terms, the x terms, and then the constant, just the one. So to put this in descending order, I'm going to find the highest. This is an x to the 5th. Now this is an x to the 5th as well. So now we got to come up with some kind of a rule. Well, what if there's a tie? And generally the rule is we just go with the highest number here because this 5 is higher than this 4, even though they're both 5th degree terms. So my guess is we're going to stick with x to the 5th. Same thing when you get down to x cubed. It looks like we have another degree. This is still a third degree. So they're both third degrees, but this actually says the number 3, which is higher than a 1 and a 2. So to put these in descending order, I guess would put the 5 first, and then the 3 would come before the, yep, nice. So descending order. And then ascending order would be just the opposite. So ascending means start with the low and then head high. So again, a polynomial function is a nice smooth function. Anything with like x to the third, x to the fourth, x to the fifth, any x to the integer is going to be a nice smooth continuous function. And so we're going to determine some points, an ordered pair, an x and a y value. So we could just make a quick little t-chart and plug in for x and solve for y. But notation for that is, this is let your x value, so this is p sub x. Remember that will find y. So if we let x be 2 everywhere in this function, instead of writing 3 times x cubed, we could write 3 times 2 cubed minus 4 times 2 plus 6. And then either you could just take your calculator and number crunch this, or you could multiply this out. 3 times the, excuse me, let's do exponents first. 2 cubed is 8, and 3 times 8 is 24. 24 minus 8. 16 plus 6 is 22. Again, I'll show you on the very last example here how to just plug this into the calculator so we don't have to do any of this work at all. Same thing here. In fact, let's just go to our calculators. Because if I'm going to ask to evaluate several points on the same function, usually it's a little bit easier to go to, I'm going to deactivate this function, hitting enter. So I'm going to type in my y sub 2 function, so that way when I get to the last example I've already got it typed in here. But let's go ahead and type in this as well. 3x cubed, sorry, I did squared. 3x cubed minus 4x plus 6. The first time I graph, I always like to hit zoom 6. That'll give you a standard 10 by 10 by 10 screen. But this is really the fastest way to evaluate functions very quickly. Just hit trace to enter, and there's that 22 that I was looking for. And then if I wanted to evaluate it, the -3, I just type in the -3. Make sure you don't hit the gray key. That's a minus key. And I get -63. So that's honestly what I would probably do on this one. What did I say? -63? Yep, -63. So instead of doing all of the math, we can just number crunch it on our calculators. So like terms can be collected, which means combined. So for example here, I've got a 3x to the 4th and a 4x to the 4th, which can be combined for a total of 7x to the 4ths. If we keep looking down the line, I can combine some x cubed terms. -2x cubed because 1 minus 3. Moving along, I got x squared terms with no x squared, so I'll just keep the -4x squared. Then I've got a x term here and an x term here for a total of 8 x's. And then I'll just do 7 minus 1. This 7 minus this 1 gives me a 6. So again, collecting like terms. And this is the additive inverse, which really just means we're going to be, instead of adding, subtracting. You may want to rewrite this. X cubed minus 4x squared plus 6x plus 7. I kind of even like to stack this. So I'm going to distribute this negative and stack like terms together. Distribute this negative, find a like term, so -x squared. And distribute this so it's a +5 and just stack it on top. So I'll add going down now. So 1 take away 3, -2x cubed minus 5x squared, just bring down the 6x and add. So I distribute, stack, and add. Kind of a nice method to combining like terms. It's a little bit easier to see than, this is called adding horizontally. I kind of prefer adding vertically. Makes it a little bit easier. So here was that last question that I was kind of talking about. This says estimate 25, so you're really supposed to kind of be thinking about what happens if you plug in a 25 to all of this. Well, I'm going to cheat. I'm going to go to my calculator. I'm going to clear out that second function that we did. And I've already typed in, just for the sake of time, that first function. If I hit zoom 6, though, I only get a 10 by 10 by 10 viewing screen window. So if I try to hit trace 25, let's see, maybe it wasn't done graphing. Maybe I didn't activate it. Yep, let me activate this again. So I have to hit enter. So then if I hit zoom 6, I get a nice graph. What the function looks like, I don't really care. I just really want to evaluate and let x be 25. But I want to show you what happens if I don't set my window. If I hit trace 25 and then press enter, I get an error message. And what it's saying is, you can't let x be 25 because if I go under my window, well, I have to hit number 2 first, I guess. If I go underneath my window, I'm only looking at the x max 10 units to the right because I hit zoom 6. And that set it. So I actually have to look a little bit further to the right. I could go out to 26. I'm just going to go all the way out to 50. It doesn't really matter what you choose. And I don't have a very good viewing screen here either. I could look higher up, but I don't really care about that. I'm just going to hit trace 25 and then press enter, and it evaluates it. 288.2 is the solution that I'm looking for. So that's the fastest way to evaluate for a function. Just use your calculator. Just make sure you got your proper window screen so that when you're hitting trace some x value, your x max is actually going out to that value. So again, to estimate this, I would say around maybe 300. I don't know, somewhere between 250 and 300 would be a pretty good estimate. I'm not a big fan of estimation because I don't know really what they're rounding to, but your calculator, no need to estimate because your calculator finds the correct solution. I hope this was helpful. Email me with your questions. Goodbye.